Hi, my name is Jared Anderson, and today I am coming to you at the WebSphere User Group talking about Liberty and Jakarta EE. So my role at IBM currently is the WebSphere Jakarta EE Development Lead, but I'm also the WebSphere Performance Team Lead. So I'm going to try and do a presentation that kind of covers both of these to give you a little bit of perspective on what's happening with performance when it comes from a Jakarta EE perspective as well. So first, I'm going to give you the normal disclaimer slide here. So I will be talking a little bit about some plans and directions of where we're going at IBM, but those are subject to change. So do not make any decisions based off of the things that I say today on when product shipments will happen and things like that. And also from a performance perspective, your mileage may vary. We are running in a controlled environment when we're doing these tests. In your environment with your network, with your hardware, it may be different. So first of all, I want to talk about a little bit, give some history here about what is Jakarta, where did Jakarta come from? So originally Jakarta started out with Jakarta EE8, which is the exact same as Java EE8, just with different company that's doing it. So it moved over to Eclipse open source. So there is no content difference between Jakarta EE8 and Java EE8. But in EE9, things did change. So as part of the move to Jakarta, that there is some trademarks and that needed to be handled. So Oracle decided that we needed to have everything to not be Java X. That is their standards of what the package names have to be. Additionally, all of the namespaces change in all the description files. So this is the one re-release. The only change we're doing here is changing things from Java X to Jakarta. There are a couple of small things that are removed in Jakarta EE9 as well, the J2EE management, and a couple of things within the EJB spec that has been deprecated for a long time. And with some of the changes that are coming in newer versions of Java, those will go away. So this is about a year ago when Jakarta EE9 first was introduced. Final specifications were released. A final compatible implementation was created with Glassfish, and it was announced at Jakarta 1 livestream last December. So once you have a first compatible implementation, usually being Glassfish, the first one to come out of the box is usually going to be a vendor implementation. Then that for us with Liberty, we were the first vendor compatible implementation out there. So with 21.002 beta, we released the web profile compatible. We didn't quite have everything ready yet for full platform. And so in 21.03 beta, we released that as well. So this is the 9.0 compatibility. One of the things that didn't happen with Jakarta EE8 and Jakarta EE9 is they didn't have Java SE 11 support. So that was something that, in order to keep that date of last November, they removed that from the 9.0 specification. So in response to that, they created a 9.1 release. So that came out this past May. And similarly, Liberty also decided, hey, let's try and be one of the first out there to be a compatible implementation. Well, at release date, not waiting for after release date, we were also compatible. The funny thing is, we were already compatible with that 21.03 beta release, and that's the exact same release that we used to show our compatibility. And that should not be a surprise since Liberty has supported Java 11 for nearly 3 years now. So it would not be something that you should have been shocked by. So we're very happy to see that we were able to do that without having to wait for a later implementation version. Next, I want to talk about what's coming. So Jakarta EE10. So like I said, 9 is the same as 8 except for changing things from Java X to Jakarta for their package names and changing those deployment descriptors. With Jakarta EE10, now we can actually see some introduction of changes into the specifications besides those removals of some of the older specification pieces that I talked about in EE9. So you're going to see in EE10, it's been many, many years since Java EE8 was introduced. So this will be the first time that we'll see changes in this Enterprise Edition technology. So you're going to see things like RESTful Web Services 3.1. RESTful Web Services, the new name for JAX-RS you may have heard in the past, Jakarta Servlet 6.0, and about 20 more other updates coming in specifications. Now, the slide here says that we're looking at having these individual components completed by end of year. This is being from a specification perspective. they are running a little behind in the community. So I don't know whether we're going to quite make end of year. So it might be sometime early first quarter. Once we have all the individual specifications and all the components that are necessary to create the web profile and platform, that will be completed. Their plan is for first quarter, but as the individual components aren't completing on time, that also could bleed into second quarter. In addition, with Jakarta EE10, they're looking at having a new core profile. So these are going to be those core technologies that are mostly part of what you know as MicroProfile. The MicroProfile technologies out there. So that's, the CDI, the annotations, the RESTful web services, and the JSON technologies. And if I didn't say CDI, CDI will be actually called CDI Lite. It will not require everything that is in CDI. So with Liberty, like I said, we were able to get an implementation out there very early on. It was in beta, and I'll go over some more details on when it's coming out to be generally available. We took a two-prong approach on how to become Jakarta EE 9 and 9.1 compatible. So obviously we worked with those different open source communities that have different technologies for those different Jakarta componentries. And if they were having a Jakarta EE 9 implementation, we looked at pulling that into the product. Otherwise, if they didn't, which not everyone did, or maybe we have our own implementation within the product, in there we looked at trying to transform the code instead of having to duplicate the code and have the dual maintenance and not having to do it all multiple times and having extra cost of maintaining it. So in order to do that second part there, that transformation, IBM took a leadership role here within the community and created what's called Eclipse Transformer. It's an Eclipse open source technology that allows you to transform your bytecode or source code, or even just your XML files or any other files that you have that you use in order to do your work, potentially property files, where you're tracking different things for your different technology. So it's a generic transformer technology. We use it for Jakarta transformation, but it can be used for other reasons within your applications as well. So this allowed us to do some very rapid development and also updating all our tests as well, so that we didn't have to duplicate all the test work. We can transform those on the fly and then rerun the tests with the Jakarta EE 9 features instead of the Jakarta EE 6, 7, or 8 features that we're testing with. Additionally, other companies, picked this all up as well, and they're using the same exact technology and creating their EE 9 offerings. You'll see there's a nice blog post explaining this in a little more detail on how you use the transformer. And then I also earlier this year made a video showing how to use the transformer, use that what is in that blog post, talking about how we did it and how you can do it, and actually did it with DayTrader 8 and showing you how to do a more complex application, being able to transform it, within seconds, with some of the extra work and maybe take an hour to 2 hours to do it, a Jakarta EE application like DayTrader 8 and have that be able to run on Jakarta 9. Additionally, I was able to transform your server configuration as well, the server XML. So I highly recommend going to that blog post and following that video. Additionally, with Jakarta EE 9, I talked about there is the deployment descriptor changes, there is the package name changes. We also Jakarta had to do some changes of the feature name, the short names of the features. So, I talked about Jakarta RESTful Web Services instead of JAX-RS. The abbreviation JAX-RS is a trademark owned by Oracle, and they did not want to give that trademark over to the Jakarta technology under the Eclipse Foundation. So Eclipse Jakarta ended up changing all the feature short names for all the different technologies. To align with that, we thought that Jakarta 9 was a good time to do that, to update our short names for our features. We weren't required to, but we thought it was a very ample time to do that. So to give some examples here, like I talked about earlier, JAX-RS, RESTful Web Services, JPA is now called Persistence, JCA is now called Connectors. We did make a few exceptions. So concurrency has been out there, but we've always called it concurrent. So we just left that one. It's very close to the name. It was the name in Jakarta EE and Java EE. So I'm leaving it concurrent, worked for us. And additionally, Jakarta's short name is just security. We've always called it app security. So similarly, when Jack and JASPIC changed their names to authentication and authorization. We added the word app there. Authentication, authorization are very generic, so that could cover a lot of different technologies that we have within Liberty. So we added the word app there in front to align with what we've done with the security componentry. If you decide, you're currently trying to move over, that the major version is going to change and it's going to be a .0, and you were put in there JPA-3.0 instead of persistence-3.0, the server is not going to start because we're not actually have a feature named JPA 3.0. But we also added in the technology in there so that if we do detect that old short name with the new number, that we will let you know and give you a nice error message when you start your server to say, hey, the actual name now is persistence 3.0, for instance. Other thing I want to talk about with what's coming with Jakarta EE9 and what's out there currently in beta is we introduced a new JAX-RS implementation, or as I called it earlier, RESTful Web Services. So JAX-RS 2.0, 2.1 implementation in Liberty uses Apache CXF open source technology. So with that, we decided to switch over to using REST Easy with the RESTful Web Services 3.0. The main reason we did this is from a performance perspective. And so it kind of fits in that I get to talk about it here as well, with me being the performance team lead for WebSphere. The performance team here at IBM for WebSphere looked at the different JAX implementation and other different ones out there. And we noted that REST Easy was outperforming CXF. So we thought Jakarta EE9 again was the right time to make this transition to a new implementation, because most people have to update their application significantly in order to use Jakarta EE9 because of the name changes for the packages, etc. With those internal measurements of the old versus new, so JAX-RS 2.1 versus RESTful versus 3.0, we see about a 7 to 20% throughput improvement, and I'll go over that a little bit more on the next slide. So here's where I said a 7 to 20%. So we have a very simple app here in the top left. So this is called a ping perf app that all it does is do a simple, relatively hello world REST call. So it's just measuring mostly the cost of doing a REST call and back. So this is, not going to be a lot of payload coming to and from it. It's just sending over a ping relatively and coming back and saying, yep, I got it. So we saw about 20% throughput improvement there. Very happy with that. Similarly, there's an application out there in open source called REST-CRUD, and that just does a call that relatively is doing CRUD operations, doing a get, an update, a put, a remove, etc. And so with that, again, we saw, 20, 21% performance improvement. They're very happy with that result as well. We took a little more complex application that's not just doing REST operations. So the Acme monolith application, we converted that over to Jakarta EE9. It doesn't just do REST function. So you're going to see, obviously, a drop there in the amount of improved throughput because there is other operations happening in there with servlets, JMS, etc. Different operations happening besides just REST. So that's why obviously you expect to see a little bit of a drop, because we didn't see an improvement in those technologies because we're not changing those. We just transformed those. Only where we actually made a new implementation is with the RESTful Web Services function. And there's a spec application out there where we did do some transformation. It's not official because it doesn't run with Jakarta EE9, so I'm not going to give you the name of that benchmark, but it does use REST function. And with that, we saw about a 12% improvement. So just to give an idea of why, as the different application technology companies out there are making their Jakarta EE9, why would you want to go with Liberty? So I'm going to try and answer the question, why Liberty over everyone else? So one of the things that the performance team does on a regular basis each year is we do some updates to some performance presentations to give you an update on how Liberty is doing compared with the different other technologies. So this was done earlier this year. So some of the things may have changed in version numbers, but at the time that we did this, it was the version numbers that were actually available. We used the containers that were available for those different technologies. And so they're properly tuned for that technology company's decisions. So Wildfire, JBoss, Pyara, for instance, on here. The reason I chose DayTrader 8 is, again, DayTrader 8 it should be the same as JTrader 9 because all we do is transform it. So the technology is the same under the covers except for obviously the RESTful web services. So you'd see that boost there, but how will we compare across the board? So these charts here show that, from a startup perspective and a footprint perspective, we're doing, about half the amount of time it takes and half the amount of memory to actually start up and be able to get to that first request. Actually first response to a request. And then additionally, we look at the bottom chart here, you can see the throughput. And with the throughput, again, we're almost 40% faster than these different companies' implementations for Java EE 8. And you'll see even on the first and second chart, we did do an improvement on ourselves over time as well. One of the other things that we did this year, besides just look at startup footprint and throughput, one of those 3 of those key metrics that we keep track of and make sure that we don't regress on, we decided to do a little exercise to say, how are we doing from a scaling perspective? As the number of clients to an application server increases, are we scaling well? Or are we falling back or starting to flatten out? And we also did a comparison with other technologies out there. Again, this is JTrader 8, just looking at throughput. As the number of clients increased, we see the throughput increase nicely. Against the other implementations that are out there, they kind of level out. Once you get to those 20 to 30 clients coming in, things start to level out. So very happy again with the results here showing how well we are doing with scale. Additionally, one of those other metrics that's out there a lot of times is, well, great, you got a lot of throughput, but you use a lot of memory. So we also said, hey, well, what is the throughput to memory ratio, right? How much throughput can we get per how many megabytes? And so we took, again, a look at that. And again, Liberty did quite well and, levels out nicely and doesn't continue to grow as you see the throughput increases, the memory's not increasing extra over time. And then another metrics that we have many customers keep on asking us about, and so we decided to make sure we included it here, is response time. So yes, you get great throughput, but you're not getting that response time. And customers many times will start to get upset saying, hey, we're not getting the response time. As we increase the number of clients, response time continues to go up. And you will see some of that just for the cost of things like garbage collection and, reading things off the network, etc. There is a cost as you increase because there is additional work happening with additional threads over the same number of CPUs. But again, Liberty is doing very well on keeping that cost down and trying to keep a balance there between throughput and response time. So where is it currently at? I've talked about Jakarta EE 9, Jakarta EE 9.1, both being being available in beta, and we want to eventually get that to being generally available. So there was a couple of things that kept us, to go from earlier this year to where we are now. There was a lot of work to happen besides just having Jakarta EE 9 compatibility and having the product being ready for that to be generally available to be used in production. Our current plan, like I said, this is subject to change, is to be 21.0.0.12. That'll be coming out here in the next couple of weeks. For 9.1 to be generally available in that release. We're going through all the approvals, performance, serviceability, etc., that we need to go through to make sure that it is a good quality release and good quality feature before we actually say that we are going to put it out there. The things that kept it from being done earlier is some of those value add features within Liberty. So both in Open Liberty and in WebSphere Liberty, when this becomes generally available, all those will work correctly with Jakarta EE 9. So if you change your server XML to start using Jakarta EE 9 technologies, but you also have some value add features within Liberty, those will continue to work. Most of those retain their exact same feature, version number and feature name, except for a few that have that older name in it. So like there is one called WMQ JMS client. Well, we changed that to WMQ messaging client because the new name instead of JMS is messaging. So there's a couple of ones like that, but in general, we try to keep everything to keep their old names from a feature name perspective and a version number for those value add features. And under the covers, they just are going to handle the difference in the Jakarta technologies. Additionally, we certified before with 9.0 that required Java 8. 9.1 required Java 11. Again, 9.1 does not remove Java 8 support, so we were able to also, certify that with Java 8. With now the introduction of Java 17 a couple months ago, we're looking at also certifying that with Java 17. So this new release would have 8, 11, and 17 certification if the community accepts 17 certifications. Additionally, you might ask, well, what about MicroProfile? You've talked all this stuff about Jakarta, but obviously MicroProfile is built on top of Jakarta technology. So MicroProfile specification has been working on a 5.0 release. That's his plan to work with Jakarta EE9. Again, the only changes really in there are to do the package changes from Java X to Jakarta. That should be finalized by the end of the year. Again, that's the specification being finalized. That's not our implementation. Part of that requires you to have a compatible implementation. Liberty is doing a lot of work to be that compatible implementation for the different technologies within MicroProfile, but that will be in our betas. We can't actually GA it and make it generally available until after the specification is finalized and the APIs are finalized. So we're kind of currently looking at that being 22.0.0.1. Again, it's subject to change. If the specification does not finalize on time, we will end up having to delay that to probably 22.0.0.2. And that's just because we are having to wait for the specifications to complete. So that is what I wanted to cover today from a Liberty and Jakarta perspective. We will have time for questions. I know that Neil's probably been monitoring some of those during the call here. We'll take some of those at the end, but I am not the only speaker today. We will also have Mark Studley today be presenting about the Java side of it. So I'm going to pass over to him.
Thanks, Jared. So yeah, I'm Mark Studley. I'm the Chief Architect for IBM Java, and maybe we can switch to my slides now. Just wait to make sure. Okay, it has happened. All right. So I'm going to talk today about what's been happening in Java at IBM. And one of the big pieces of news for Java at IBM is that we released our own JDK distribution called IBM Summary Runtimes, which comes in 2 editions, open and certified edition, back in August. I'm going to talk about all the details on this slide in the upcoming slides. This is kind of an agenda slide and a wrap-up slide I'll show again at the end, but there's lots of information here I'm going to tell you about Summary Runtimes. In particular, Summary Runtimes have a really strong focus on providing excellent performance and memory footprint when you're running containerized Java workloads or containerized workloads in the cloud. And so there's a lot of work here that we've done. I'm going to tell you about some of that work and why it's beneficial, as well as some of the ongoing work that we're doing here in providing really innovative features for Java-based workloads. And finally, for those of you who are on the mainframe and have been waiting a long time to get the Java 11 on ZOS, I'm happy to announce that the Runtime Certified Edition for ZOS version 11 is going to be GAing next week, if all things go well, and you'll be able to use that. So I'll spend a slide talking about that as well. So let's dive into it. So IBM Summary Runtimes, there's a website there, ibm.com/summary-runtimes, that you can go and find out some more information about this. This is basically an open JDK class library runtime distribution. It's built by IBM, and it's powered by the Eclipse OpenJ9 JVM, so it doesn't use the hotspot JVM. So unlike all the other JDK distributions out there, which are really people just building OpenJDK as a mechanism to provide more efficient fixes to their customers, the OpenJ9 JVM truly does represent an innovative change in what the runtime performance that you can expect from Java applications that you run on the IBM Summary Runtimes. On the right side, I got a small picture here showing you where the name Semeru comes from. So Mount Semeru is the tallest mountain on the island of Java in Indonesia. I like to say it's the part of Java that's in the clouds, as an homage to the fact that it really is built for cloud-based performance. The runtimes are available at no cost. They're very stable and secure. They've been at the base of IBM's Java software business for more than 15 years at this point. So Fortune 500 companies, as well as all of IBM's software-based products that run on Java, have been using this technology. It's very stable, very secure, high performance, optimized for the cloud, and available across a very wide variety of platforms, not just the platforms that you would traditionally associate with IBM, i.e. IBM Power and the mainframes. It's also available on x86 for Windows and on Mac OS as well. It's ready for production and development use, again, at no cost. and very thoroughly tested with the Eclipse Aquavit testing framework, which is something that originally came from the release testing framework that IBM has used for decades to test its Java releases. As I mentioned previously, it's available with 2 editions, and these are 100% compatible editions. So it doesn't matter which one you use from a functional standpoint, but there are certain differences between them that might be attractive to certain customers versus others. The open edition is available with an open source license. That's the GPL v2 plus ClassPath extension license. That's the same as every other JDK distribution that's out there that's based on OpenJDK. It's available for Java versions 8 and 11 and up. 17 is not quite available yet because OpenJ9 has not yet finished its Java 17 release, but that will be coming shortly, hopefully by the end of November. There is also a certified edition. This one is released with an IBM license, and it has been TCK certified. So we have run the Java SE TCK certification tests, and it passed. And this version is available for Java 11 and forward, and will be available for 17 when it's ready as well. As I mentioned, these 2 editions are 100% compatible with one another from a functional standpoint. So which one you choose depends basically on which license you're more compatible with and whether you care about TCK certification. These JDKs are available at no cost. You can use them for any deployments you want. However, if you are interested in commercial support, IBM does have a commercial support offering called IBM Runtimes for Business, where you can, there's some very flexible options available for the workloads that you want to be supported on, so that you can get fixes on a more more quickly than you could get from the regular quarterly updates where you get security fixes and bug fixes. The bottom right part of this diagram is kind of a quick summary of some of the performance results that you can get with OpenJ9, and one of the reasons why we say it's very well optimized for Java in the cloud. So much smaller footprint, much faster startup, faster time to peak performance, especially in resource-constrained environments, which is common when you're running with containers, and all at very little impact to performance, overall throughput performance. Let's talk about this a little bit more. So when you're looking at choosing a JVM or JDK for running your Java in containers, you have to recognize that containers is a very different kind of performance environment than when you're running on bare metal. And when you're thinking about performance and the environment where you're running, there's a lot of metrics that need to be taken into account. And a wide variety of use cases means that you have to really balance what you do to improve on these metrics. You can make one metric, you can make yourself perform really well on one metric, but that will frequently have a cost in one or more other metrics. And so when you have different goals, like the different goals between running on a bare metal environment versus a containerized environment, you have to make different design decisions all the way into the JVM. There's no single right answer because you have to run lots of different types of Java applications, and everyone's got a different answer. And that means making sensible trade-offs among all of those metrics. Some of the metrics that we're tracking with OpenJ9 are startup time, ramp-up time, memory footprint, response time, and the more traditional CPU or throughput designs here. And so I'm going to make the statement that optimizing for containers really requires a different balance across these performance metrics in order to be fully effective and most effective when you're running Java in containerized environments. Of course, many people, when they're running containers, are running Java in the cloud. And one of the things that's true about cloud is it's basically computing on demand, right? So there's the resources that your Java workloads consume cost money much more directly than when you're running in bare metal machines. And so there's a number of things that we've sort of broken this down into. So where does OpenJ9 provide advantages in terms of the resources that your Java can consume? The first is we can make your deployments very small. We need to obviously recognize what the resource limitations are that are being imposed by the environment so that we don't make mistakes and think we have more resources than we really do. But even being aware of those limits isn't good enough. We should really be using those resources very judiciously so that we don't use resources that we don't need because we have to pay for those resources. And finally, in the cloud, it's a much more elastic environment where you're creating new instances and pulling instances down. You want to be able to start JVMs very, very quickly because startup time is basically a time where you're consuming resources, sometimes substantial resources, but you're not actually getting very much bang for your buck because you're not ready to process transactions or do the work that the JVM is being started for to do. Now, why is this important to you? Why is all this JVM stuff important to you? Well, in Java, the real owner of the resources is the JVM. You don't actually have direct ownership of a lot of the resources that get consumed when you run Java workloads. It's the JVM that's allocating memory. It's the JVM that's creating threads, and so on. So using an efficient JVM can provide a very efficient substrate for running your Java workloads. So with OpenJ9, we basically have the mantra of keep each container small and scale out new instances quickly. So let's look at these in a little bit more detail. So small deployment size basically means having a small container image, right? So there are a number of good things that come with this. From a security standpoint, there's a lower surface area for attack. For developers, it's a reduced push time. When you're scaling out nodes, it's a reduced pull time. So these things all combine to be very helpful when you're running containers. There are three basic recipes that we have that exist for making your image size smaller. The first one is that you can use a JRE package instead of the JDK package. The JDK has a number of development tools that are very useful for developers, but aren't very useful in terms of a deployment, that deployment time. And so there's no reason to pay the space for those when you're deploying your Java applications. The second thing is if you're using Java 11 or later, you can use JLink to eliminate the modules that you don't actually require. And again, just get rid of the bytes that aren't being needed by your Java deployment. And finally, you can pick a smaller or a different operating system base image to make your container smaller. So this little chart here shows a point in time from a while back of the sort of different container sizes that you can get by exploring some of these options. We're just looking at the AMD64 platform for now. You can see that the Ubuntu and UBI images with the full JDK are around 150 megabytes. If you are able to reduce the OS image size down to use Alpine, you can get that down to about 117 megabytes. So that's a pretty substantial benefit for almost no cost to do. If you go from JDK to JRE, you can get all the way down to 81 megabytes. So that's even more impressive. And if you combine them together, you can get down to about 50. So there's about a 2/3 saving in container size that you can make very quickly just by employing two of the three recommendations that we've got here. I put some links here just to let you know that there are, well, actually, that's not the right link. This should be the official link, so that should be an underscore. The IBM Summary Runtimes, JDK 8 and JRE tags, just to give you a flavor for what these tags look like. Now, how do you get these smaller base images? We only make a few images, our images available with a few different bases explicitly. But with this small set of command lines or code lines to put into your Docker file, you can actually get a different base image. So this first line just says we're gonna take something from the IBM Summary Runtimes. In fact, what we're gonna do is just copy the JRE out of the Summary Runtimes image and put it into a different base OS image. The from Alpine says we're going to actually base this image on Alpine, the smaller OS image. And then the next lines copy from Summary the JRE into the current image, which is based on Alpine. And after that, we've got a JRE inside an Alpine OS image. So with very little work, we reduced as the last slide showed, our 150 down to 117 megabytes just by including these 5 lines in our own Docker file. So very easy to do. Moving on to the second one, which is being aware of the limitations that are being imposed by the environment. So the phrase we use for this is container awareness in the Java ecosystem. So OpenJ9 is container aware all the way from Java 8 and up by default. This slide shows some of the problems you can get into if you aren't container aware. So for example, you can get confused about how much memory is available. So if the container limit is 1 gigabyte and you run that on a host that's 16 gigabytes, if the JVM somehow isn't aware that the limit is 1 gigabyte, it'll set a heap size based on the size of the host, and 4 gigabytes, you'll throw out of memory, badness will ensue. Similarly, you can make the same mistake with the number of CPUs that are available. Container limits might have only one processor available for the container to run in. but the JVM could think it has all 64 CPUs that are available on the host, with the result that you'll get too many GC or JIT threads allocated by the JVM. Application thread pools will be confused and allocate too many threads, and you'll basically just saturate the system with too much work. So, being aware of the containers can avoid these problems, either getting killed because you've run out of memory, or getting better performance because you're at a better scalability point in terms of the execution frames. Now, using container awareness, as I mentioned, it's available by default. There's an option that is available that's enabled by default. Use container support. There are a couple of other sort of usability things that are associated with this. If for some reason you don't like setting a maximum heap size and let the container, as the container scales, let the JVM scale the heap automatically, we've actually adjusted the default heuristics that the JVM uses to decide what maximum heap size to use. So the little table on the right here just shows that inside a container, the JVM will use a more aggressive memory limit than if it's running outside of the container. And the reason for that is, if you're running Java inside a container, it's probably the only thing that's running inside that container. And so it's more likely that the memory is really intended for the use by the Java process. Whereas if you're outside the container, the odds are there's other things running as well, and you don't want to overload the system by grabbing it all just for Java. A better approach, however, is to use these max RAM percentage and initial RAM percentage options, which allow you to say that you want Java to allocate a percentage of the available RAM in the container. So for the example that I've shown on the right here, with the RAM percentage set to 80%, if you set a 2 gigabyte container, you'll get 1.6 gigs of heap. If you have a 4 gig container, you'll get 3.2 gigs of heap. This allows you to better scale the heap with the size of the container if that's what you want to do. The advantage here, of course, is that if you need more memory for your app, you don't necessarily have to go in and change both the heap size and the container size. You can just change the container size in one place, and the heap will scale. All right. But even if you're aware of the limits of the environment, you don't necessarily want to use all of the resources if you don't need them. And this is a connection back to the fact that computing resources cost money. So if you don't need to use them, don't use them. Don't spend money you don't need to. The cloud is really about sharing, right? And you don't want anybody being greedy and using all of the resources that are available. You want to share and use only what you need, so that more resources are available to other things if they need them. Some of the things about OpenJ9 that contribute to this are the fact that OpenJ9 uses single word object headers, which are very memory efficient compared to what Hotspot uses. And that means that OpenJ9 by default just uses less memory overall. And it can make a big difference when you have lots of, is there a question?
Yeah, just there's a question related to, I think, what you covered just a little bit previously. Largu is asking, so we only have to set max RAM and initial RAM, and does this apply also to Liberty on VMs?
Yeah, you can use the same those command line options. You can add to your server XML to set those command line options for the JVM, and it will apply to how much memory the Liberty instance will use as it runs inside the container.
Okay, and the recommended max heap size for use in a container, is that also something that differs?
It's something that varies depending on your application. It all comes down to how much of the memory you need for the heap versus how much of the memory you need for native allocations. Like if you allocate a lot of direct byte buffers, then you'll want to, allocate let the heap have less of the space in the container so that you have enough space for your direct byte buffers, etc. Or if you have, if for some reason you have a very large number of threads, you'll need memory to be allocated for those threads, etc., for the stacks and everything. So it really is one of those numbers that varies a lot by your application. You're going to have to evaluate it for the memory uses that you have in your app.
Okay, thanks.
Okay, thank you. All right. So getting back to OpenJ9's use of memory. So the single word headers obviously is something that can matter quite a bit if you have a lot of small objects, but it's just an overall reflection of how OpenJ9 takes memory consumption very seriously. Another aspect is that OpenJ9 is very conservative with heap growth. So if OpenJ9 doesn't think that more heap will help provide a faster response time or increase throughput, it's not going to grow the heap. It will try to keep the heap actually quite small. And finally, OpenJ9 aggressively tries to free memory that it's used transiently during execution. One big example of that is JIT compilation. So JIT compiles take a lot of memory, and OpenJ9 aggressively tries to free and disclaim the memory that had been used by JIT compilation in order to keep the overall memory footprint down for the process. And just so you can see the effect of these, the graph at the bottom shows a very simple run of Acme Air application measuring memory footprint under load. And you can see that, as the container size varies from 1 to 2 to 4 gigabytes, OpenJ9 is not using more memory. The load is the same here, and therefore the delivered throughput and the memory required here is the same. That's not actually the case for Hotspot, whereas if you're growing the container, it's actually growing the size of the heap that it's using. So OpenJ9 in this case, if you don't need the heap to deliver throughput, you shouldn't be growing the heap and consuming resources that cost money. So OpenJ9 can be more efficient here. You might also wonder, how are you supposed to know how much memory the JVM needs if it's going to just expand and consume whatever you give it? It's a lot easier to do a run and find out how much memory it needs and then size your container appropriately if the JVM is being more efficient like this. All right, and the fourth area where OpenJ9 helps here is with faster startup. And this is faster startup without any kind of language restriction. So I'm not going to discuss about native image or anything like that here. These are facilities that OpenJ9 has developed over the last decade to improve Java performance for all kinds of Java startup performance for all kinds of Java applications. The primary accelerator technology here is called a shared classes cache, or SCC. It's essentially a memory mapped file on most platforms, which stores the read-only parts of classes so that they can be read faster into memory and loaded faster into the JVM. In addition to classes, we can also store compiled code. So we cache the JIT compiled code that we generate in one run of the application so that we can avoid paying that JIT overhead to get high performance code in later JVM runs. We also call this dynamic AOT, but I actually prefer the term cached JIT code. And finally, we also store some profile data in this shared class cache, so we can learn from earlier runs and do a better job of accelerating and getting back to high performance in subsequent runs. Summary Runtimes Docker images have a pre-built SCC, also called a system SCC. This one includes a number of JDK classes that are commonly used during Java application startup, and they provide an immediate boost in startup right out of the box. So you don't have to do a first run and then only get the benefit in the second run. With this pre-built SCC, you get the startup benefits right in the very first run. You also have cached JIT code here, which has been generated with a portability option setting. So we're not targeting the JIT code for the most the exact processor that you generated the code for, but because containers tend to get deployed on different machines or can get deployed on different machines than the machine where it was actually built, we've kind of loosened a little bit the requirement on what levels of the processor we're going to target and generate more portable AOT code. So we lose a little tiny bit of performance for doing that, but it means that the code can be used across a wider variety of machines, and so you're more assured of getting that startup performance wherever that container ends up being deployed. Another interesting thing we did here was to build a shared class cache in layers aligned with the way that Docker containers are built in layers. And this is a really great benefit, because otherwise, the shared class cache that you would introduce at a very low layer, like the JDK layer, for example, you would have to allocate a cache that's large enough to be able to hold all of the classes and code that later container layers would want to use. So if you imagine a JDK layer with a Liberty layer built on top of it, and then an application layer on top of that, the JDK would have to predict how much space it needs for Liberty and for the application. And how's it going to do that across a wide variety of applications without allocating way more space than you would actually need in a real environment or in a real case? Also, because of the way containers work with its copy on write for files, and the shared class cache is a file, once an upper layer changes the cache or adds new things into the cache, it actually Docker makes a complete copy of the existing shared class cache. So that results in some very inefficient memory usage across when you start using shared class caches, traditionally shared class caches with Docker containers. So we changed how they work so that you could build them up in layers. And that means that you can allocate just as much space that you need in your layer for the classes and code that you have in your layer. And then later layers can build on top of that and size their shared class cache layers based on how many classes and code they need to add as part of their runs. And so Liberty takes advantage of this as well. And your applications that are built on top of Liberty can take advantage of that too. Finally, there's an interesting little thing we did with called a class relationship verifier, which tries to avoid actually loading some classes that are triggered when the class loads are triggered by verification. We defer those until later so that they don't actually get loaded by the verification process itself. And this can avoid enough class loading that it has an impact on startup performance. And there's a command line option -XX plus class relationship verifier that you can use to turn on this facility. It's not turned on by default. Just to give you a little bit of a concrete idea how these all fit together, this graph, which looks a little bit complicated, but I'll go through it in sections. So there's 3 sections here, left to right. One of them is startup time. The middle one is footprint RSS. That's the amount of resident set memory that's being consumed under load. And the right side is image size, so the size of the container. And it's for a Spring, the pet clinic example for running with Spring. We're running here with 4 processors and 512 meg containers. Each of the bars reflects some of the technologies that I mentioned on the previous slides. The reference for all of these is the blue bar on the left, which is hotspot, which is pegged at 100% for normalization. And then you can see the improvements that happen. So let me just go through the startup time data to start with. So you can see that originally with OpenJ9 in an earlier version, which did not have the system SCC or any of the other things I talked about on the previous slide, you can see that OpenJ9 startup performance actually was slower than hotspots by default. And that's because we were focusing, if you weren't using our shared class cache command line options explicitly, we assumed that throughput was all you cared about, and that's what we focused on. However, as we added in the class relationship verifier, which is the gray bar, and the system SCC, which is the yellow bar, this is the 4th bar, basically the middle bar of the left section. Now you can see that brought us basically on par with hotspot. And so, from a out of the box default standpoint, startup for OpenJ9 and hotspot are about the same. But once you start employing the -X share classes option and starting to cache the classes and code from the actual application and not just from the JDK, those are the 3 bars on the right. And you can see that there's a substantial improvement here, almost 50% reduction in the startup time for basically all the 3 options that we provide here. So we're looking at 55%, a 45% improvement essentially in startup time. So that's pretty dramatic, and no impact to the application. You didn't have to do anything special here to the application in order to get this kind of startup time improvement. I'll switch now to the middle set of bars, which is looking at footprint under load, how much memory the JVM is consuming. And you can see here that, hotspot is, as the reference point, you can get about a 30 to 35% improvement in memory performance just by using OpenJ9. So that's memory that you don't have to pay for if you're running in containers and in the cloud. Finally, on the right-hand side, we can see the impact of some of these things to the package size, the image size that you get with the container. Initially, OpenJ9 was actually a little bit smaller than the image that hotspot would come in. But again, once we got our system SCC and class relationship verifier in place, it's kind of on par. Now, the right 3 bars are the point where you're starting to cache substantial classes and code from the application and your application framework. So remember, this includes Liberty as well as the pet clinic application. And you can see that does have an impact on the size of the container, but the payback that you're getting in terms of almost half the startup time and 30 to 35% improvement in footprint is, I would say, worth it in this case for sure. And we're not stopping there. Those are all things that are there already. There's more cool stuff here and coming on the way. I'll just talk about two of them very briefly. The first one is the JIT server technology that we just GA'd in October with the October update. It's now available in our Java 8 and Java 11 IBM Summary Runtimes packages. The basic idea here is that you can separate the JIT compiler, which is normally an integrated part of the Java virtual machine. You're not even very much aware that it's there. It just kind of operates to accelerate the performance of your Java application. We've separated that out, or can separate that out, into an independent service that runs independently of the JVM. And the benefit here is that the JVM client becomes much more predictable in terms of its resource usage, and it has much lower peak resource requirements. So the graph on the right here shows Acme Air and that footprint under load option. You can see that the orange bar, which shows what's happening in the client when you're running with a JIT server, is much more regular and lower than the memory performance that you see from OpenJ9 when it's just running with a JIT inside itself. So these spikes that you see in the blue line are JIT compiles happening primarily at the beginning of the run, but they're there. And it means that you need to size your containers in order to accommodate those JIT compiles, because if you don't, then you're going to suffer some performance impact, because those compiles are going to blow out of memory. And it won't kill the container. We're better than that. But it does mean that certain compiles won't be able to compile at as high a level as you'd prefer it to be. And so there may be a performance impact if you can't do those compiles. Whereas with the orange line, those compiles are happening. They're happening on a separate server. Why would you do this? It's a good idea because of that peak performance. You don't have to allocate container size for peak performance. You can now allocate container size for what your memory load is, the load of your application, which allows you to pack applications more densely. And this is particularly suitable for cases where you have low utilization servers that aren't being driven at 100% all the time. They're running at 15, 20, 25%. They still need to be there, and you still need to allocate memory for them in terms of their container sizes. But if you can make the containers smaller, you can pack more of those applications onto a system without consuming all the memory or consuming all of the CPU budget, and thereby save money because you don't need to allocate as many nodes. And we've seen deployment size cost savings of up to 33% here using the JIT server technology. So it's a pretty cool one. I encourage everyone to look into it. The second one I'll talk about on the slide here is a JVM checkpoint restore using CRIU. So this is a technique that we're building on to make Java startup even faster than what you can see with the shared class cache technology that I talked about earlier. So we're kind of taking aim at the native image kind of performance levels that you can get. But we're doing it in a way that we think we can deliver it very quickly, and we can do it with very few and maybe even no restrictions on Java language feature use, which will be a good advantage relative to native images. So the idea here is that you take a snapshot of the JVM process after, for example, startup performance, or after, just as you're ready to start processing transactions. And then all you have to do when you want to deploy that JVM is you restore the process, and then it's able to start processing transactions right away without having to rerun the code that you would normally run at startup. The JVM itself provides services so that frameworks like Liberty and applications can adapt to the environment in which they're restored to, right? If the number of processors has changed, or if the amount of memory is different, or if the date and time are different at the restore point than they were when you built it, etc. Those kinds of things, so that the new process can operate as if it were started at the time when you deployed the application. And as I say, this is with little to no restrictions on the Java language features that you would use. So dynamic class loading works fine, reflection works fine, etc., with no changes to the application. On the right side, we're showed a sort of prototype performance result that we've had here just to sort of test the waters on how well we think this could work. And so this shows 3 different applications: Ping Perf, Acme Air, and Day Trader. The blue bar shows the startup time roughly without CRIU, and the orange bar shows the startup time with CRIU. And you can see that there's kind of a 5 to 7-ish kind of X performance improvement in terms of startup time. So that's a fairly dramatic startup time improvement. And it comes without as many restrictions on the application. So we're quite excited about this technology. It's not ready for production yet. It's something that we're looking at for 2022, but we'll have to see when when it all comes to fruition. But we're quite excited about this one. All right, almost finished. So coming soon here, we have the IBM Summary Runtime Certified Edition for ZOS. That's our mainframe operating system, version 11. So this has been one that's been a long time coming, and we've all felt bad about how long this has taken to come to fruition. But I'm finally able to talk about our planned GA, which is basically next week. So it's finally coming. This will be providing ZOS developers with the ability to use Java 11 finally and stay in step with the Java levels that they're using on other platforms. It does have a few prerequisites in terms of the ZOS versions that are supported and the hardware supported, which is from the ZEC12 kind of level. It's basically part of ZOS. So the pricing is no charge, and support is entitled through ZOS. So it operates just the same way as the IBM SDK for Java operated for Java 8. We've now rebranded it as the IBM Summary Runtime Certified Edition for ZOS version 11. Is there a question? Nope.
No, there will be, Mark. So if we can wrap up, that'd be great.
Okay.
There's a few questions. Yeah.
Yep, I'm almost done. All right, so basically on the ZOS platform, this is essentially the same thing as we've released on other platforms. It's just been tailored now for operating in the ZOS. It uses the latest OpenJ9 Java Virtual Machine, which exploits the latest Z hardware. It includes the OpenJDK class libraries implementation, including the OpenJDK security implementation. It does include the JSOS batch launcher and the toolkit with APIs so that you can access ZOS specific files and system services. There are a number of mainly security-based modules that will be enhanced going forward in service refreshes with this release. But we're very excited to be getting this one out the door finally, and happy to be able to put it in our customers' hands. So finally, just one last thing of where you can get IBM Summary Runtimes on their distributed platforms, but not ZOS. There's an IBM website that you can go to. It's very easy to find. There's a download page which has all different links for all the different packages that you can get, signed or not. There is an official image. There are official images at Docker Hub and the IBM Summary Runtimes organization. You can get the Open Edition, 8 or 11, and JRE or JDK. Certified Edition is coming. 17 is coming, etc. And I'll wrap up here because I've said most of this stuff throughout the presentation, so I won't just go over it again, but I'll leave the slide up so people can read it if they're interested, and I'll stop there.
Okay, great. Thanks, Mark. We do have a few questions specific to both sides, and maybe I'll start with you. You covered a bit of the performance around comparing to Hotspot. But is the whole Adoptium suite and so on covered with that as well, or do you have any other comments around performance?
Well, around performance, all the performance that we focus on here is with OpenJ9. So IBM Summary Runtimes is always includes the Eclipse OpenJ9 Java Virtual Machine, and provides all of the fast startup, low memory footprint, faster time to peak performance, and more or less no impact to throughput performance. Your mileage may vary on all of those things, right? It's a Java virtual machine. As I mentioned, it has to target literally an infinite variety of Java applications and requirements. So there are some where the things I said are going to be true. There are some where the things I said may not be quite as true. But we're always happy to hear about areas where we can improve, and our focus is definitely there.
Right, and Jared, I know there was a question about the recommended runtime for Open Liberty, and maybe you could comment on the performance characteristics, when you cover that as well.
Yeah, I don't know if you can switch back to my slides, but I did bring up, if you can, I did bring up my slides again to show that DayTrader 8 slide talking about the different performance of running the different Docker images that are available for each of the different runtimes, the application servers. And with that, we are using the runtime that comes with that Docker image. So for Open Liberty perspective, WebSphere Liberty perspective, we are always running with a IBM runtime technology, now called obviously Summary. Summary didn't exist when we did these numbers, but it would be the exact same here. Similarly, on the other application servers, their Docker images come with a hotspot technology. Usually, sometimes they do use a different technology for Java runtime, but usually they're going to be using Hotspot or Adoptium. Again, under the covers, it ends up usually being a hotspot-based technology. So that's why we usually would recommend that you are using an IBM Summary technology that's built on top of OpenJ9, like Mark talked about. They work really well together to give you these type of numbers that both Mark and I expressed. If you were to use a hotspot technology here, you would see that startup and footprint would be about double, similar to what Mark showed, but similar with these same technologies, you would see that same exact impact to startup.
Okay, great. And Mark, back to you. Is there a plan to have some kind of clustering for the JIT server?
Clustering. So what this is actually an area that we're still exploring. So the technology has now been GA'd as part of Eclipse OpenJ9, and it's included in the IBM Summary Runtimes. The deployment for JIT servers, we've been looking at looking at a Kubernetes operator to be able to deploy the JIT server itself in a fairly automatic way. What we've been finding is that one JIT server per Kubernetes node is kind of a good, tends to be a good sort of level of deployment, although you can get away with having one JIT server for multiple Kubernetes nodes if you don't have too many nodes. It all boils down to kind of how many JVM clients you've got and what the workload is. So this is definitely an area that we're hoping to provide better guidance for going forward in terms of how you deploy it and how you get the most effective deployments from it.
Okay, great. Any comments to wrap up? Those are the key questions that we've had from the audience. So,
like I said, both the stuff that I talked about and Mark talked about really work really well together. We are always testing and making sure that they work, in a compatible way to give us the best throughput, best performance that you can from a Liberty perspective to run your Jakarta applications. So that kind of sums up what both Mark and I were talking about to give you the best of the best for running your workloads on the cloud.
Great. And Mark, anything?
Yeah, no, that's a great summary. I'll just let that one stand. And the only thing I'll add is that if you have any further questions, feel free to reach out to either Jared or I to learn more and to make sure you get everything out of this that you can.
Okay, great. And to our audience, thank you again for joining us for the Community Festival for this session. And please continue to follow on. There's a number of sessions going on later today that you can take part in. And there's also a workshop running tomorrow that many of you will want to take part in that covers these topics. Thanks again.
Thank you.